Welcome to the lesson on constant of proportionality. Before we jump into this concept, I want to return for a second to a problem that you've already done on the front page of this packet having to do with proportional relationships. And I want to remind you that in this problem, the rice had a consistent unit rate of 60 cents. You were able to find that. No matter how many pounds of rice you bought, you always get 60 cents a pound. That's because this is a proportional relationship. The paper towels, there was no consistent rate. The price is different depending on whether you buy 3, 4, or 5 rolls of paper towels. This is not a proportional relationship. There's no unit rate. Similarly, at the bottom of this page, you most likely found that this was the proportional relationship. And there's a number that should jump out at you when you look at from 7 to 21, 8 to 24, 9 to 27. And that number is 3. 7 times 3, 8 times 3, 9 times 3. These other tables don't have that number. This is a proportional relationship. These are not. And so that's what we're looking at when we're talking about constant of proportionality. We're interested in that number that defines a proportional relationship. And that number is called the constant of proportionality. Let's define it. The constant of proportionality, the COP, is the number that can be multiplied by any x value or any input to get the corresponding y value. Now let's break that down for a second before we continue. If I have a table like the one we just saw, I know that to get from any x value to the corresponding y value, all I have to do is multiply by 3. 7 times 3 is 21. 8 times 3 is 24. 9 times 3 is 27. So if I have an x value of 10, all I have to do is multiply by 3. The y is 30. If I have an x value of 15, all I have to do is multiply by 3. The y is 45. No matter what x value we put in, we are going to multiply by 3 to get to 45. In this relationship, the constant of proportionality, which we also use the letter k to represent it, is not 5, it is 3. The constant of proportionality is the number that we use to get from x to y with multiplication. Let's write just a few more things. As you saw on the front page, the constant of proportionality has the same value as the unit rate. In the rice problem, the constant of proportionality was 0.6 because 0.6 or 60 cents times the pounds of rice gets you the total cost. It's the same as the unit rate. Let's also write how to find the constant of proportionality. To find it, we divide y divided by x. In fact, an even better way to write that is that k, which is the constant of proportionality, is equal to y over x, because that means y divided by x. Okay, let's see how that works in action. The cost of renting a bike is shown in the table below. 0 hours is going to cost me $0, 1 hour $6.50, 2 hours is $13, and so on.
I have to figure out the constant of proportionality, aka k, which I remember is y over x, and tell what it represents in the context of this problem. So looking at the table, I can see that for each of these, there's a really clear number that I'm going to be multiplying by. The only way to get from 1 to $6.50 is times 6.5. And 2 times 6.5 is also 13. But let's just show that that works. K is equal to y over x. So I can pick any y and x value, any pair from the table, and put it into this formula, and I should get the constant. In fact, you see right away that that's 6.5, that's the y, over 1, which is just 6.5. This would also work if I did 13 divided by 2. 13 divided by 2 is 6.5. It would also work if I did 19.5 divided by 3. That's 6.5. This number, in the context of this problem, represents the unit rate. It's the unit rate. And let's say what that means. It costs $6.50 per hour. Now let's use the constant of proportionality to complete this table. So to get from 5 to this y value, I'm going to have to do some multiplication. 6.5 times 5. Every single value in this table to get from x to y, I multiply by 6.5. So 6.5 times 5 is 32.5. $32.50. To get from 8 to how much it costs, I'm going to multiply by 6.5. And that makes sense, because if you have 8 hours, you're going to have to multiply those 8 hours by the cost per hour. So 6.5 times 8 is going to be $52. Alright, let's look at a different problem. The distance an ant traveled over time is shown in the table below. So there's some information given, but then there's some things that are missing. And I need to find the constant of proportionality. Okay, so I'm going to remind myself by annotating that the constant of proportionality, which is k, is equal to y over x. It's y divided by x. And we need to do the same thing, find what it means in the context. Now be very careful when you see a problem like this, because right away a number jumps out at you when you're looking at these pairs. And you're probably thinking 4, which is great. But the constant of proportionality is not 4, because 4 times 4 doesn't equal 1, it's 16. 8 times 4 doesn't equal 2, it's 32. So to find the constant of proportionality, we're going to take any y and any x and plug it in. So the constant of proportionality k is equal to, I'll just pick this one, y over x, which is 1 over 4. So it's not 4, it's 1/4. And that makes sense, because 4 times 1/4 is 1. 8 times 1/4 is 2. 12 times 1/4 is 3, and so on. So if I want to find how many miles this ant traveled in 1 hour, I'm going to multiply by 1/4. And it's 1/4 of a mile. And if I want to find how many miles this ant traveled in 17 hours, I'm going to multiply by 1/4. And that's where I might need to do a little bit of side work. So 17 times 1/4, well, that's 17 over 1, which is 17 over 4. And if I convert that to a mixed number, it's going to be 16 and 1/4. And finally, if I wanted to figure out how many hours it took to go 0 miles, well, I just need to use some common sense that if the time hasn't started yet, if he hasn't traveled any, so if he hasn't traveled any distance, then he has not traveled, he hasn't spent any hours traveling. And that makes sense as well, because 0 times 1/4 is 0. In fact, every relationship that is proportional is going to start with 0, 0. Okay, and the last question is how many miles will the ant travel in 40 hours? Well, we're going to do exactly the same thing. 40 times 1/4, which is equal to 10. So the ant traveled 10 miles. All right. Good luck with your practice. Check with the control, and see you next time.